Hello, everyone. Welcome to our first keynote of the Brazilian Symposium on Software Quality. In this special edition, 20 years, it's a pleasure to announce Professor Ian Bosch as our international speaker. Professor Ian Bosch came to Ouro Preto, state of Minas Gerais in 2009, 12 years ago. He was our international keynote speaker when he introduced the transition from software ecosystems, from software product lines to software ecosystems, actually in Brazil for the first time. I was there giving a tutorial on software reuse management, and we talked a little bit on the topic. He motivated me to investigate software ecosystems based on my master's work on business aspects of software reuse. In fact, I finished my master's with a discussion on software ecosystems, and my PhD and ongoing research are mostly on this topic. Thank you again, Professor Ian Bosch, for accepting our invitation. Let me introduce you to the participants. Ian Bosch is a professor at Chalmers University of Technology in Gothenburg, Sweden, and director of the Software Center. Earlier, he worked as a vice president engineering process at Intuit, where he also led Intuit open innovation efforts and headed the Central Mobile Technologies team. Before Intuit, he was head of the Software and Application Technologies Lab at Nokia Research Center. Previously, he headed the Software Engineering Research Group at the University of Groningen. We received a master's degree from the University of Twente and a PhD degree from the Lund University. His research activities include digitalization, evidence-based development, business ecosystems, artificial intelligence and machine deep learning, software architecture, software product families, and variability management. He is author of several books, including Design and Use of Software Architectures, Adopting and Evolving a Product Line Approach, and Speed Data and Ecosystems, Excelling a Software-Driven World. Editor of several books and volumes and author of hundreds of research articles, he is editor of Journal of System Software and Science of Computer Programming. He chaired several conferences as general and program chair, served on many program committees, and organized countless workshops. Ian is a fellow member of the International Software Product Management Association and a member of the Royal Swedish Academy of Engineering Science. In the startup space, Ian is an angel investor in several startup companies. For more information, see his website, ianbosch.com. Now it's time to talk about quality in the age of ops. Professor Ian Bosch, feel free to share your thoughts, experiences, and insights on the field.
Thank you very much, Rodrigo. That was really kind and impressive that you still remember the time when I went to Ouro Preto. That was a few years ago when I was a lot younger. I also have to learn not to send such a long bio because you read most of it. But in any case, I am honored to be here, and I'm really glad that I have the opportunity to share my thoughts on this. And since this conference is focused on quality, I wanted to talk about one perspective of quality in the age of ops. And once again, I will leave time for questions at the end, but I have a quite long presentation. And if you feel very strongly about jumping in and asking questions during the presentation, don't hesitate to stop me at any time. It's not my intent to get through all the slides. It's more to have a good time and a good conversation with all of us. So once again, I want to thank Rodrigo for introducing me so kindly, and for the organizers to thank them for the invitation and for all the help that they gave me to set this up. And what I was hoping to do is to basically dive into the content. So quality in the age of ops. And for those of you, and I know that some of you already saw the slides, but for those of you that went back and read a book from the 70s that was a bit of a classic, the book is titled Zen and the Art of Motorcycle Maintenance. This is actually an inquiry into what is quality. And I think that that's an interesting thing, because what I will try to do during the talk, after we get through some of the preliminaries, is to talk about what is it that we actually mean with quality, and is maybe the traditional test-driven, do I match the requirements kind of way of thinking on its way out, and are we ready to start replacing it with something else? So I will read the quote to you, but I mean, I think that that's, for those of you that have read the Tao, you will recognize this, but basically quality, in a way we know what it is, but in some way we also do not really know. So we know that some things are better than others, and that they have more quality. But if you try to define what it is that makes something have quality, then it all goes poof. That's basically what I've noticed in many cases. Some things are better than others, but what is betterness and what is quality? What is it really? And that's what I was hoping to spend some time on with all of you, because I think that within software engineering, we have taken a bit of an oversimplification of what we consider to be quality. Very often, many teams that I work with focus on requirements, test cases to match requirements, and they feel that they have achieved quality when they have built what it says in the requirement specification, and the test cases show that that's what we're actually doing. And what I'm claiming is that that's not what it is all about, that there are actually broader ways of thinking about this. And that's what I was hoping to cover in the presentation. So the first thing is that I was hoping to cover some topics here in the age of ops, and I think that many of you are aware of this, but in the community, especially on the practitioner side, terms like DevOps, Data Ops, ML Ops are used quite extensively, and I think that those are important topics to talk a little bit about. The second is that when I talk about quality and in software engineering, I believe it's important to realize that the world has evolved beyond the traditional software and the notion of continuous deployment. We also need to become much more aware and work with what does data mean in this context, and what does artificial intelligence mean in this context, and how do we work with this? Because these things are becoming part of an integral whole: software, data, and AI. And then the point that I'm trying to make in this keynote is that I believe that we need to adopt a broader view of quality and basically develop and engage on developing a set of tools that effectively address this broader notion of quality. And that's what I'm hoping to cover with you. And again, I'm happy to engage with you with all of you in discussions. So what I was hoping to discuss is give you first a little bit of an introduction and background of who I am and where I come from. Then I want to dive into digitalization, because it's such an overloaded term that I just wanted to make sure that everyone has the same understanding of what do I mean when I say digitalization. Then I want to dive into the meat of the presentation, which is the age of ops, where I want to talk about the three digital technologies: software, data, and AI, and talk about quality and what quality means in those different contexts. And I hope that that is at least interesting and relevant for you. In the interest of time, I have a section on functional safety and ops. I think that many of you are aware of that products such as cars, healthcare equipment, to some extent also telecommunications equipment, even in the financial industry, there are lots of regulations that need to be followed, and specifically functional safety, which is the certification and regulatory compliance around ensuring that our products are safe, is often viewed as being at conflict with ops, DevOps, and other types of ops. And what I wanted to do, if I have the time, is to dive a little bit into what does this mean, and then finally we get to conclusions. To be honest, judging the clock and my tendency to wax a bit too eloquently about the topics up to then, I'm not sure, actually I'm pretty sure I will not have time to cover it, but I'm happy to engage with any of you after this keynote presentation to discuss and deep dive. So for those of you that do not know me, you already got the introduction, so I will not spend much time of this. I spent around half my professional life in the industry, working for Nokia in Finland and for Intuit in Silicon Valley. And these days, I divide my time between a number of different things. I have appointments at Chalmers University of Technology and at the Technical University Eindhoven in the Netherlands. I run something called Software Center that I'll discuss on the next slide. I have a small consultancy where I work with a variety of different companies around questions on the boundary between business strategy and technology strategy. I'm on a number of company boards here, specifically at Swedish companies, and I work as an angel investor in the startup community and have a number of investments that are currently actively ongoing. So that's my background. But my main job is to run Software Center. And Software Center is a collaboration between 18 companies these days and 5 universities, with the mission of significantly improving the digitalization capability of the European software-intensive industry. And I apologize for drinking tea and water during the talk. I have the worst cold in several years, actually, so my voice is far from optimal, but I hope you can hear me. So the companies in Software Center include companies, Swedish companies like Ericsson and Volvo Cars and Volvo Trucks and Scania and Saab and Tetra Pak and similar companies. But also a Finnish company, Wärtsilä. We have Danish companies like Grundfos and Dive. We have German companies like Siemens and Bosch. So the large European players are, many of them are part of Software Center. And what we do is we, within the scope of accelerating the digitalization of the European software-intensive industry, focus on things like continuous integration, continuous test, continuous delivery and deployment. We focus on continuous architecture, so technical debt management, API management, those kind of questions. We look into metrics, and we have a colleague who is world leading in the metrics field. And we have a colleague who looks into customer data. How do we make use of all the data coming back from the field, and all the how do we look into software and business ecosystems, the topic that Rodrigo was already referring to. And then finally, the newest theme that we added last year is the notion of AI engineering. So then we talk about all the engineering solutions that are required to successfully deploy machine learning and deep learning models. We do not only work with companies that started their life as metal bending companies. Occasionally and periodically, we interact with companies like Booking, originally a Dutch startup, for those of you that are aware of the company. Spotify, Rovio, the company behind Angry Birds, King is the company behind Candy Crush. Klarna is a Swedish startup that allows you to buy things on credit online. I'm not sure if they're in Brazil, but they're very actively expanding into North America. And one of our former PhD students is now at Microsoft and the data science team in Redmond. And we, through him, stay in touch with what is happening, for instance, in some of the aspects of Microsoft. So that's my background. And where I then want to go to is just to make sure that we're all on the same page, is to talk a little bit about what do we mean with digitalization. And the important thing, why I care so much about this, and also why I run Software Center, is that if you ask the question of all the companies that were on the Fortune 500 list in 2000, how many companies are still on that list in 2014? And the answer is that in 2014, which is already 7 years ago, more than 50% of the companies that were on the Fortune 500 in 2000 are basically gone from the list. I mean, basically they haven't gone necessarily bankrupt, but they basically plateaued, or they had some major issues and lost a lot of revenue. And what we see is that there is a constant disruption taking place. And for those of you that have followed the journey of Nokia, probably realize that Nokia is just one of the cases that have been affected by this, but far from the only one. So what this means is that disruption is the new normal. And what this means in practice is that companies on average last, and now the latest research I saw was 10 years on the Fortune 500, and that time period is actually constantly decreasing. And the reason for this is that companies fail to innovate and build new core capabilities. And if we look at where the new core capabilities are required, it is in the area of digitalization. And companies that don't do this right, they basically get disrupted. What is digitalization? I hope you can read this. The background doesn't make it super, but digitalization is the use of digital technology to change a business model and provide new revenue and value producing opportunities. It is the process of moving to a digital business. This is the typical Gartner definition. And if you then go to Boston Consulting Group, you basically see that they talk about digital capabilities, digitalization of core assets, and digital and data-driven offerings and business models. And you see that things like Agile are mentioned quite a bit in that context, systems and technology platforms, but also analytics and data integration, the digital partner ecosystem. Those are all capabilities that you need to have as a company. And there's a lot more to it, but I don't want to spend too much time on it, except for stating digitalization is not just a software thing, it is actually something that affects the entire company. And what we see in the software center is that many of the software center companies are now quite good at software within software R&D. They do agile, they do DevOps, they do A/B testing, etc. But taking it beyond R&D into the rest of the R&D, into manufacturing and supply chain, into sales, into HR, those kind of places, that has been quite tricky. Often I get a question, what is it that makes a company digital? And then you get all kinds of interesting hypotheses. Things like, if I use email, am I then digital? If I have a website, or if I use social media, or if I use video conferencing, or even if I have chatbots, am I then a digital company? And we believe that there are 8 characteristics of what makes a company digital. The first is data-driven decision-making. The second is relentless experimentation, and we're going to come back to this, but basically talking about A/B testing. Then short feedback cycles. You try to operate in such a way that any decision you take, you try to get as rapid feedback as possible. Decision making is pushed down in the organization. If you believe that we want to make decisions based on data, then you should push the decision making authority to the teams that are closest to the data, because they have the best insights of how to make decisions. Strategic data collection. If you want to make data-driven decisions, obviously you will need to have the data, and often this means that you need to start collecting data before you need to make decisions, rather than retroactively, because that never works. This requires you to work with a unified data warehouse. We see that digital companies make pervasive use of AI and automation, and many times the job titles that these companies have are the same, but what people actually do in these jobs is completely different. And I think that's an interesting one that we can talk about separately. If we look at the software center companies, and as I mentioned, many of these companies started their lives as mechanical engineering companies. And what has happened over time is that these companies have added first electronics, often in the 80s and 90s. Then they started to add software, often in the 90s and the first decade of the 2000s. That was a big thing. And what we've now seen over the last 10 years or so is that data and artificial intelligence are becoming increasingly important to all these companies. And when I talk about digitalization, we talk about software, data, and artificial intelligence. So the 3 digital technologies. One of the interesting things that if you build a car, or you build a telecom network, or you build a radar system for a defense operations, or a jet fighter, or whatever, it isn't that mechanics and electronics go away. You cannot build the car without the mechanics and the electronics. But the key thing is that there are now new technologies being added to the equation. So in addition to mechanics and electronics, I have now the software, data, and artificial intelligence. And in addition to that, what we see is that it is often that the mechanics and electronics become commodity. So it's not the things that drive sales or drive value for customers, and the software, data, and AI are now the differentiating technologies. And that is actually a constantly shifting context, because if you go, for instance, to the computer gaming industry, in many computer gaming companies, software is viewed as a commodity, and it's the data and AI that are really the differentiators in, for instance, computer gaming. Another major shift that you see happen in this context is that very often the business model changes. So if your business, if the value of your product is mostly organized around atoms, so the mechanics and the electronics, you tend to have transactional business models. Whereas if the value of your product is organized around bits, so software, data, and AI, in many cases, you want to move towards more of a subscription or usage-based business model, but basically a business model that is much more continuous. If you look at it from a business ecosystem perspective, it is clear that every time that you add a new technology, you also need to add new partners and new companies and suppliers to work with, both from a knowledge perspective, but also from an outsourcing perspective, and from a basically simple product delivery perspective. And the third aspect is that we move to a new ways of working, as I already alluded to in the first part of the presentation, where we talk about Devops, which is the fast release of new software to products out in the field. data ops, where I do the same thing, but then for the data part of my products, and then ML ops, where I work with the continuous upgrading and updating and evaluation of new versions of machine learning and deep learning models. So there is a quite fundamental shift. One of the things that many of the software center companies that I work with are currently challenged with and are trying to understand how to deal with is that we're moving from a traditional value delivery model that you see on this slide, where, for instance, whenever I buy a car, that car is the best the day I drive it off the lot. That is the peak that you see there. And then over time, the car gets a little bit worse every day until I'm so sick and tired of the old piece of junk that I go and buy the next car. And the next car is maybe a little bit better than what my previous car was, but it is still the best the day I get it. And then it starts to deteriorate over time. And I keep going through this cycle. However, the industry is moving to a new form of value delivery. We're moving towards a model where we have continuous value delivery. So the product, even though it is maybe the best as we can make it on the day you get it as a user, it is still the worst it will be throughout its entire life. And this is where continuous software deployment plays a role, which can then causes the product to become continuously better. But what we now see is that companies are looking at how we use the same approach, not just for software, but also for the electronics and for the mechanics. And for those of you that are aware of Tesla, about 2.5 years ago, Tesla announced an upgrade of the electronics for autonomous drive in all Teslas since 2012. Where you could, for $5,000, basically buy an upgrade of the electronics in your vehicle in order to prepare your vehicle for full autonomous drive on the highway by the time the software that Tesla was developing had caught on. And so the software still hasn't caught on, but at least the idea is there. So the idea is I have a continuous business model, so I get paid on a service or usage-based approach. I push out continuous software updates. I periodically upgrade the electronics in the product that I have, and I occasionally, when the case really presents itself, replace the mechanics of the product. In a recent paper that was published earlier this year, and I don't want to spend too much time on this, I want to get to the quality thing, but we looked into and developed a model that looks into what happens when companies go from a traditional way of working to a digital way of working. And what we did was we identified 4 dimensions. We identified a business model dimension, a product upgrade dimension, a data exploitation dimension, and an AI dimension. And what we see is that if you look at the business model, you go from traditional product sales to offering your product as a service, to complementary services around the product, to customer KPI-based business models, which is when, rather than, for instance, in the case of Volvo Trucks, rather than getting paid for a truck and then having the customer use it, you get paid for every on-time delivery that this customer makes with your truck. And the customer basically gets access to the truck without any additional expenses. But what is happening is that the customer is paying you based on your contribution to the KPIs that the customer cares about, like the number of on-time deliveries of transports. And then finally, we can move to a multi-sided ecosystem where you take data, for instance, from one customer base that you then package and resell to another customer base. This changes the way that you think about data. It changes the way that you think about artificial intelligence. And especially, I want to talk about autonomous system experimentation, which is one of the topics I want to come back to. And then finally, there is a product upgrade dimension where you see that rather than thinking about the physical product, what I now see is that more and more companies are starting to look into a fully digitalized offering where the mechanics and electronics are still part of the product, but they're not really the defining thing. And for any of you that have an iPhone, I think that that's exactly what you're experiencing. I recently, about half a year ago, replaced my old iPhone with a new iPhone. And to be honest, nothing really changed. The phone was a little faster, it had a little bit better camera, but by and large, the same features and functionality was there. And Apple has basically been providing me with a continuously improving product that is much more of a digital offering than of a physical offering. Important here is Apple still makes the money on the physical phone because they have a decoupling between the phone and the way that they deliver the customer value, or the way they make money and the way that I receive value. And I think that that's an interesting case that we can discuss if people are interested. This is digitalization. I spent a little bit more time on this than what I would have wanted, but I wanted to get the concepts across in order to be clear that we are on the same page. So now we move to the age of ops. And I wanted to start with a quote by Elon Musk, which I think captures why we are so interested in moving to age of ops. And the quote, as you can read, says, I think it's very important to have a feedback loop where you're constantly thinking about what you've done and how you could be doing it better. And what we see is that for any system, the faster the feedback loop is, the faster you have feedback from the time you make a decision or the time you make an investment or the time you do anything to getting feedback on what are the implications, what is the effect of doing this, the faster you can do that, the more effective companies can operate. And we see, and I think that this is basing, again, a concept that is basically providing a foundation for the remainder of this talk. We see that companies in the software center and also outside of the software center are moving towards what we call a holistic DevOps model or holistic DevOps framework, where we see that within the same company, for the same product, we see 3 different types of development. The first type of development is the classical requirements-driven development. That's when you get a specification or you get a requirement set, you build according to requirements or according to the specification, and if you satisfy those, then you're actually fine. And typically companies use this for regulatory features, for competitive parity features, for commodity features, where it's clear what needs to be built, basically. The second type of development is what we call outcome or data-driven development. And this is what you have, for instance, in many online companies such as Booking.com, where especially in e-commerce, for instance, rather than saying, go and build this and go and build that, a team, typically a cross-functional team, will not get a requirement, but will basically be asked to improve a certain KPI of the performance of the system. So if you work for Booking.com, for instance, you may be responsible for one part of the website. The management may ask you, current conversion for your part of the website is 3.2%, meaning that out of every 1,000 people that come to the website, 3.32 people do what we want them to do. Your job from the coming quarter is to change the conversion from 3.2 to 3.4%. And if you can do that, then we're fine. So, and then we are basically no longer in the space of requirements and specifications, but rather now the team has to come up with hypotheses on how to change the outcome that we're interested in, and then basically run experiments like A/B testing to figure out what is the right way, what is the best way to move the needle on the KPIs that we would like to see moved. And that is what we call outcome or data-driven development. And then the third type, which I'm sure many of you are aware of, is AI-driven development, where we typically have a large data set, but almost always it needs to be a labeled data set, at least to a significant extent. And I take a machine learning or deep learning model and I train it using the data set in order to develop a model that can be deployed in the field that has minimized prediction errors or has maximum accuracy or F1 score or recall or whatever you care about in this particular case. And typically you apply this in cases where it's very hard to come up with an algorithmic solution, but it's much easier to come up with a machine learning and deep learning solution that basically learns by example, if you will. What is important is that all these components end up in the same system in operation. They are all subject to continuous deployment. So the requirements-driven, outcome-driven, and AI-driven development, all the components, the artifacts that are the result of that work are all subject to continuous deployment. And there is behavioral data coming back. So I know for every component as well as for the system as a whole, how it is performing. And this is, I think, important that also machine learning models are subject to this. And if I then reflect on quality, and this is what we're going to be talking about in the remainder of this section of the talk, the traditional way in which we have been thinking about quality is that I have a specification. I match this specification with a set of test cases. I use my continuous integration, continuous test, and continuous deployment infrastructure in order to make this happen. And then based on that, I believe that if my continuous integration, continuous test system shows that the test cases are passing at a sufficiently high rate, and I have confirmed with whoever is responsible for the translation between specification and test cases, that the test cases are an adequate representation of the, or mapping of the specification, then traditionally we have said that this is a system of high quality. And I think that this is, of course, a valid way of looking at the world, but I also think that it is a way of looking at a world that is becoming outdated. And the reason why I care so much about this is because what I see with many companies is that the specification is concerned with the customer looking to achieve a certain outcome. The customer doesn't want necessarily to have the requirements or the specification or the feature or whatever. No, instead, the customer is looking to achieve a certain outcome. I mean, this may be increased conversion, this may be a better net promoter score, it can be some other KPI. But what I've done is there is a certain outcome that I'm looking to accomplish. And what we've asked the customer to do is to convert the outcome that they're looking to accomplish to a specification. And then we live in the part that is the red box. But that world is going away. If I look at many software as a service companies, but even now some of the first embedded systems companies, they care less about the specification and they care more about what is the outcome that I'm looking to accomplish. And in that case, once I start to talk about the outcome that I'm looking to accomplish, then something else starts to become important. Then it is no longer about the test cases. No, then it is about the value model of what I want to accomplish, instrumentation in the system to collect the data that provides evidence whether the outcome that I want to accomplish is actually being accomplished or not. And then finally, I can move towards data pipelines that are basically the infrastructure that I need in order to collect the data that gets generated by instrumentation, in order to compare the value model with the data coming back from the field. And then I can determine, did I get the increased conversion? Did I get to the increased usage? Did I get the improved customer satisfaction? Did I get the outcome that I was looking for? And I think that this is a model or a way of thinking that is much closer to what the real quality is that customers care about than basically us thinking about specifications and test cases. And I know that I'm cursing in church, Rodrigo, but you know, that's what I did as well when I went from product line engineering to software ecosystems. And then the final part, which I wanted to stress, is once it is clear what my system is supposed to deliver in terms of outcomes, I do not only have to rely on humans coming up with the experiments and humans building the functionality. No, now I can actually go one step further, and within certain boundaries, I can convert part of the value model to a reward function and then use reinforcement learning, so AI algorithms, for systems to fully autonomously, without human involvement, to balance exploration and exploitation, for those of you that have looked into reinforcement learning, in order to allow the system to experiment with some parts of its behavior in order to figure out if it can fully autonomously become better and perform and achieve a better outcome, a better delivering on the value model than what I could do otherwise. And this is, if you then start to take a step back and reflect on this, you can see that the first part, specification, test cases, and then CI, CT, CD, is very much the focus of traditional software engineering. If we look at value model, instrumentation, and data pipelines, it then becomes a lot about data. And then finally, if you talk about reinforcement learning, exploration, exploitation, and reward functions, then we start to talk about artificial intelligence. And I believe that the value model, what is the outcome that the customer is actually looking to accomplish, is much closer to what we should mean with quality in software engineering than what I have traditionally seen in many software engineering conferences and contexts. So what I will now do in the rest of this part is to basically go through the software, data, and AI bits and basically provide some color or commentary on the work that we are doing in that space, and then we can discuss afterwards how people feel about this. So the traditional thing is we have developed a model that we've called the stairway to heaven, which is a typical model based on dozens of companies that we've worked with on how do companies evolve over time. And I think that many of you will recognize this, but starting from traditional development, we typically see that the first step is that the software R&D part of the organization adopts Agile, so then you get Agile teams. Once I have Agile teams, many of these teams are a bit frustrated about the fact that they may build the software, but they don't know how it works. And what then happens is that the company moves towards what we call continuous integration. This is where I have the verification and validation department and the R&D teams work hand in hand in order to build the test infrastructure, the build and test infrastructure, to allow me to very rapidly and give me feedback on whether the software that I'm building is actually delivering the value and is satisfying the test cases that have been defined. Then, once I have continuous integration in place, I basically am continuously on production quality, and the software can be deployed on a continuous basis. And then many companies move towards continuous deployment of Devops. And this is not just something that the Amazons and the Bookings and the Skyscanners and the Microsofts and the Intuits of this world do. Now, also companies like Ericsson today are releasing software every 2 weeks to customers that want to have new versions of the software. This is coming to the embedded systems industry as well. And actually, we ran a workshop on functional safety and continuous deployment about a month ago here in Software Center, and lots of companies are trying to figure out how to get there. And then finally, once you have continuous deployment, you can start to use your R&D as an innovation system, where you can start to run A/B tests and other kinds of experiments on your products in the field in order to learn and figure out what works and what doesn't work. So this is what we call the stairway to heaven model, but this is where many companies move through. And to be honest, when I started to run Software Center in 2011, almost all companies were very much focused on adopting agile practices. And now in 2021, all companies in Software Center are trying to figure out or have figured out how to get to continuous deployment of software. So we really see an evolution of the system taking place there. An important side note, and this goes to product line engineering and other kinds of things, is that for companies that release multiple products, when you move from infrequent releases of software for products out in the field to continuous or very frequent releases of software, you can no longer afford to rely on manual processes. So what you then see is that many companies move towards what I call platform for DevOps, where there is a single code base. I have an automated product derivation tool, and anytime any code gets added to the single code base, the automated product derivation tool generates the software for all of the products in the product family, and then the continuous integration and test environment basically runs the tests on each of the products in order to figure out whether the latest check-in of code broke anything or if everything is still working as it should. And I think that that's an important part. In this context, a number of years ago, we developed what we call the continuous integration improvement method. And the most important part here is what I think is the continuous integration visualization technique. This is already a few years ago, but if you Google the CIVET model and my name, you should be able to find the associated papers. But the idea was basically that this model allows you to create a visualization of all the testing activities that take place in the company. And in this graph, you will have two directions. The x-axis is concerned with the frequency of testing, which can range from immediate and minutes to once per release. And on the y-axis, you have the scope of testing. And this depends a little bit on the company, but typically we identify something like the component level, the subsystem level, the partial product level, where I may have maybe some simulated parts, the full product level, the release level, and then testing at the customer. In each of the locations in this table, if you want, or this graph, you can place a little box like the one that you see in the middle right part of your screen, where you see the F, Q, L, and E. And what we have done basically is that we indicate at that particular point in the graph what percentage of functional requirements is being tested. So the functional requirements, we then view the functionality that you are currently working on. What percentage of legacy functionality is being tested at this phase in the test cycle? The quality requirements, what coverage of quality requirement tests is being done, and then edge cases. And I don't have time to go into edge cases. If people have questions around that, I can talk about that. And then we put a line around this, and the line indicates the level of test automation, which can go from dark red, which is this is purely manual testing, to fully automated. And a way in which this can look like is this was at one of the software center companies several years ago, where they still had a separate manual release organization, but within R&D, they basically had a system where every developer in his or her own sandbox had basically, because of test-driven development, a rapid test of all the tests that the developer had developed for the feature that he or she was working on. Then the software was upgraded and integrated into the team sandbox. And in the team sandbox, a larger percentage of test cases was being run. This was, of course, fully automatic. If the software passed the team sandbox tests, it would go to the single branch acceptance testing, which is the one that you see all the way to the left, but at the top, where the system would basically do a number of smoke tests on the new functionality to make sure that within the context of the entire system, things work properly. And then this company had 3 major fully automated test initiatives, where every 2 hours, all code that was checked in over the last 2 hours was integrated into an executable and then run. All the test cases were run that fit into a 2-hour window. Then every night at 8 o'clock, they kicked off a 10-hour test suite, integrating all the software that had been built during the day into the new latest version of the product. And then a whole suite of tests were run in the 10-hour window. And then during the weekend on Friday night at 8 o'clock, they would kick off a 50-hour test suite, which would basically run from Friday night to the night between Sunday and Monday. And by that time, if you passed all of that, you were pretty confident about the quality of your software asset. At that point, the company had a separate release organization as well, which did a lot of manual testing. That is the red lines around this. But this is a way in which you can think about testing. And this helps you to describe the current state of end-to-end testing activities in the company. It provides you a way to describe the desired state for end-to-end testing. And then you can use the gap between desired and actual state to actually prioritize improvement efforts. And we quite successfully applied this at several of the software center companies, and it was really used as a very effective tool to drive improvements in the test infrastructure. Oops. The second topic that I wanted to get into is if we move towards the data part of the system. And now I forgot to remove the builds, but you can see what I'm getting at. One of the reasons that I'm so skeptical of requirements and specifications is because what I see is that this research that was done many years ago, when some of you were not even born yet, indicates quite clearly that the majority of functionality in a typical system is never used or used so seldomly that the R&D effort invested into the functionality was not worth it. So basically, this functionality should not have been built. And this is, of course, a highly debatable question, but we conducted our own research a number of years ago with a company here in Gothenburg, and we saw exactly the same pattern. What was happening is that we had some features that were used a lot, those you have the big arrows. You have some features that are used occasionally, but a very large amount of features is never used or used so seldomly that the R&D effort into those features was actually not worth it. And I think that that's important to realize. When I walk into companies in my consulting capacity, I typically tell the people in the company, half of your R&D effort is waste, because that's basically what this graph says. Yeah, half of the features in a system should not have been built, are basically waste. But no one knows what part of the functionality is waste. And that's something that I believe requires a bit of attention. One of the approaches that we have developed in this context is what we call the HyPEX model. And the HyPEX model basically says, I have a feature backlog. I pick a feature out of the backlog, and before I do any development, the first thing I do is I specify what is the expected behavior of this feature. So that means if I add this feature to the system, what will be the measurable change in product behavior, or what will be the measurable change in user behavior that justifies the investment into this feature? Once I have specified what I expect to see, rather than building the whole thing in the kitchen sink, I can then build the minimal viable feature. What is the first 10 or 15% of the functionality of that feature that I believe gives me the most bang for the buck? So the biggest impact on achieving the expected delta in behavior. And once I get that, and this is why I need DevOps, but once I have DevOps, I can then deploy that minimal viable feature into the product. I have baselined, and then I can start to measure what is actually happening in practice. What happens really? And then I get actual data. And once I get actual data, I can start to do gap analysis, because in almost all cases, there is a significant gap between what is expected and what is actually happening in actuality. One of the things may be that you don't see any movement at all. And in that case, it's clear that the feature, which maybe was a good idea by some people, turns out to be a really bad idea, and the feature just should be abandoned. You may also be very lucky. You've only built 30% of the feature. You got all the effect that you were looking for, and there's really no need to build the rest of the feature. Why bother about it if you already got the effect that you were looking for? A more typical example is that you see some movements, but not as much as you want to see. And what you can then do is you can extend the feature, and you can keep extending the feature until the feedback that you're getting is actually starting to plateau. And then finally, there is the notion where you do get data back, there is some change, but it's really funky and you don't know what's going on. Then you realize that what you built as a feature is actually not the way that customers want to use it, and you have to change your implementation. So this is a way in which you can minimize the waste in R&D by only implementing small amounts of R&D effort and measuring the impact of your R&D effort before building a complete feature. And through that, I believe, if applied systematically, you can significantly reduce the amount of waste in R&D. A typical model that is used in this context, another model that is used quite a bit, is of course A/B testing. I think that many of you are aware of A/B testing, but for those of you that are not, the idea is that for a user population, you show 2 or more alternatives to different parts of the population, and you measure the behavior of customers. So in this case, this is an example from Microsoft that our former PhD student developed. But the idea basically here is that I have an experiment goal, which is to identify the impact of showing the discount in the weekly deal stripe. So I'm trying to learn whether something helps or not. And what I want to accomplish is I want to increase engagement with the stripe, and I do not want to have a decrease in purchases. So I want to have at least as much purchases as I had before, but I want to have more engagement with the stripe, which is the part below the computer games that you can see there. And I don't think I've played any of these games, but some of you undoubtedly have. And here we see 3 alternatives. The A is the control, where there is no prices shown and the games are manually ordered. In the B alternative, the games are manually ordered and the prices are shown. And then C is based on what I know about the customer. The algorithm automatically selects the games and shows the prices. And that is then the C alternative. And now, normally when I have a live audience, I'm asking people to predict whether A, B, or C leads to the better outcome, but I don't have a live audience, so I will just go straight to the answer. And it turns out that treatment B decreased engagement with the stripe, where the games are shown, without decreasing purchases. So people still, as many games were sold as earlier, but users engaged less with the stripe than what they did before. And treatment C increased engagement and increased the amount of purchases made. So in this case, you have a very data-driven way of actually answering the question of what is going on. In this context, we've developed something that what we call, or I referred already to something that we call data ops. It's a well-known term. We didn't define it. It's developed in the industry, but it's a general methodology to design, implement, and maintain a distributed data architecture. One of the things I really stress in my talks these days is that in modern software systems, the data and the way that you manage data is as important, if not more important, as the functionality in the system. And I think that as a discipline, we have to become much better at managing data in parallel to functionality. The idea in data ops is that you blend software development techniques and agile management into data analytics pipelines. And the idea, of course, with data ops is to shorten the time required to build insights from raw data. In this context, we've developed something called value modeling. And value modeling is concerned with a hierarchical approach of modeling the value that you are looking to get out of a system. And for most cases that we've worked at, we typically see that there are 3 layers, sometimes more, sometimes less, but typically 3 layers of metrics, where at the top I have high-level metrics. Typically, these are very much related to the business. Then I have system or product level metrics or subsystem level metrics even. And then I have team and feature level metrics. And the idea is that you, at the lower level metrics that I have at the bottom, they tend to move relatively fast. The high level metrics tend to move relatively slow. And what I'm trying to figure out is to create a hierarchical model where I define the interface and dependencies between lower level metrics and high level metrics. And there's some examples here, like daily and monthly active users at the team feature level, and then the ratio between premium and standard users at the system level, and then ARPU, which is average revenue per user, which is very important in many industries, at the business level. And what you can then do is you can, by specifying these things, you can then get to the value model that I was mentioning earlier. We have a systematic process that I will not go through and discuss in detail. What I will instead do is basically, and I show the same slide here, show you a few examples. So at one of the companies that we work with, we went through a process where we first basically identified what are the different features that we could apply value modeling to. Then once we have picked a feature, here we have then selected the feature, we can start to identify what are the key value factors that we want to measure. In this case, this was a mobile app for pilots and cabin crew for airlines, that in their mobile app, when they get their monthly schedule, they can choose to request to drop certain trips and get them replaced with another trip. So if you're in Brazil and you are a pilot, and then you're asked to fly to Europe once again, or to Amsterdam once again, you can then request to get the Amsterdam trip dropped and get it replaced with something else. And then if you look at the value factors, we've basically been looking at, here are things like, what is the feedback time, what is the success rate, what is the number of users, etc. Once you identify key values, you then go and identify what is the direction in which you want these key value factors to move. And then when you do that, you start to prioritize. And what you basically do is you give them a relative weight. Here we went between a weight between 0 and 1, and the total sum had to be 1. And then basically you can then get to a fully, sorry, as I said, I have a quite bad cold. I get to a full value function where I can basically describe what is the value of this feature, and if there are alternatives of the feature, I can then see if the value goes up or if the value goes down. We've applied this at many companies. This is a automotive company, and we looked into adaptive cruise control, where we went through the same process. We did this with a company in Germany that builds parts for electric bikes. where we also looked at different parts of the hierarchy of a value feature. I don't have time to go through this in all detail, but once you have a value model and you want to start to change things or influence things, you can then start to formulate hypotheses. Once you have a hypothesis formulated, you can identify what are the data points that you need in order to test this hypothesis. And then you can identify what are the actions that I need to take in order for me to be able to collect the actions or the data points so that I can confirm or disprove the hypothesis. And we do this here as well. So we have the hypothesis and then actions to test the hypothesis. We have a data ops maturity model. David Isamatos, the Brazilian PhD student that graduated earlier in August this year, is the second author on this paper, but there are a few other people involved in this as well, where we basically say that companies go from ad hoc data analytics to full data ops. We've worked on what we call a conceptual data pipeline model, where we basically describe for a data pipeline what the different stages in the pipeline are and what the different actions are that happen on different stages, like authentication and fault identification and other kinds of things. We've looked into what are the challenges that companies experience when they work with data. In this paper, we look at it over the different phases of a typical data management case, where you move from data collection to exploration to pre-processing, etc. And we have multiple cases there. We've looked into automatic data validation. So can you, in a data stream, basically identify things like missing values, changing statistical distributions between different data streams? Can you see over a window over a data stream that certain things, the variation of the data set or the average or the mean of the data set is starting to shift? And then once you detect issues, you can then trigger mitigation strategies. You can select the optimal mitigation strategy and then make sure that you have a high quality data stream by inserting automatic data validation. Sorry, my builds were not super. What I want to do in the interest of time is spend the last 10 minutes on the AI part of our work, where we, among others, are looking into the reinforcement learning part with several of the companies in Software Center. And here I want to spend a minute on why do we care so much about what we have called AI engineering. There was a paper published now 6 years ago by people from Google, who talked about the hidden technical debt in machine learning systems. And if you look at this picture, you see that in the middle of this picture, there is a little black box that says machine learning code. And then what the authors identify is that in order for this little black box to function, it needs all the other boxes around it: configuration, the data collection, the feature extraction, the data verification, the analysis tools, the process, the serving infrastructure, etc., etc. And this is exactly what we see with all the companies that we work with as well. So if you look at the typical machine learning, deep learning model of get the data, create a model, train and evaluate the model, and then deploy, we see that everyone and their brother is talking about creating models and training and evaluating these models. But if we look at where the energy goes, where the time goes for most people that I work with, and the companies that we work with, we see that it's the getting high quality data that is can be used for training and evaluating, and then deploying models with the monitoring and the automatic retraining and the logging and everything else around it is actually, those are the things that are the hardest to accomplish in practice. Again, there are several studies. The slides will be made available afterwards, so I will not talk about this. This is a bit of an older study from a few years ago, where we look into what are the challenges around machine learning and deep learning. This is another paper by Lucy, as well as some of us in the Agile conference. We did a literature review where we looked into, for all the papers that describe real world industrial AI systems, what are the challenges that they are experiencing, what are mentioned in the literature. So this is an overview of that. And one of the things that we did with one of our PhD students, Mary John, is we developed a ML Ops framework where we talk about the data pipeline, the modeling pipeline, and the release pipeline. And if you're interested, feel free to look at the papers. One of the things that we did, and I want to spend a minute on this before I start wrapping up my talk, is we had several dozen cases that we have looked at. We have had several identified tens upon tens of challenges, I think 50 or more. And based on that, we developed an AI engineering research agenda, which is organized around the 4 stages of a typical data science project. So get the data, create a model, train and evaluate, and then deploy. And then based on that, we basically defined the agenda organized around AI engineering, where we identify architectural development and process challenges. And then around domain-specific engineering, we see work around cyber-physical, safety-critical, and autonomously improving systems. And for instance, David, our Brazilian PhD student that now graduated, was looking into autonomously improving systems, so reinforcement learning. Yuchu, a Chinese PhD student that we have who works in Volvo Cars, looks into A/B testing of models. Iris, an industrial PhD student from Siemens, is looking into how do I convert data, operational data coming back from the field, into tactical and strategic data and insights that product managers and salespeople and others can actually use in practice. Aishwarya, an Indian PhD student, is looking into data versioning, dependency management, and the data pipelines work that you just saw. Lucy, a postdoc that recently left, is looking to monitoring and logging. We had Theodore, who looks into labeling. We have Hugo, another Brazilian actually, who now works for Ericsson, who was looking into heterogeneous hardware. Menu, that I already mentioned, is working on design methods and processes. And then we have Hong Yi, who's looking to federated learning and into reinforcement learning. So the thought that I wanted to leave with you with is, for those of you that are not familiar with reinforcement learning, this is actually a really interesting field where you use the value model that I described earlier to have the system fully autonomously experiment with parts of its functionality in order to improve its performance. And in this case, we did this with Ericsson in a real world radio base station, although this was in a test setup, but there were a real base station and real mobile phones. And this was work done by David. And what we there did was we basically built a multi-armed bandit algorithm, which is a reinforcement learning algorithm, where we explored the space of parameter settings for a system in order to improve 2 factors, as you can see here. On the one hand, we wanted to decrease the maximum transmission power because of power usage and energy usage and other kinds of constraints. And on the other hand, we wanted to maximize the cell range. And we had a balance between those. So we knew how much increased cell range was valuable versus how much transmission power. And then all the circles you can see here were basically experiments that the algorithm ran. That's just the multi-armed bandits that you see on the top of the graph, and the size of the circle was the performance or the reward function that the algorithm basically delivered. And he found, and that's the red circle, what is the optimal balance between transmission power and cell range. So this is maybe a very specific example, but what I'm trying to communicate is that imagine systems that fully autonomously improve the performance based on the KPIs or metrics or factors that you care about. So imagine a system that isn't just static when it is put in operations, but is rather continuously testing and evolving itself. For me, that is a system that has a higher quality than what a system that does not do that. That is basically static from the day it is put in operation. And we have cases where this is explicitly asked. I mean, our friends at Saab, you know Saab because you're looking and I think evaluating the Jaws Gripen jet fighter. But Saab had also built a lot of radars, and several customers have asked people at Saab, Why does a radar work equally well 2 seconds, 2 minutes, 2 hours, 2 days, and 2 weeks after I've activated a radar in a certain location? Why doesn't the radar get better? Because it learns from its context and it learns to perform better over time. That is exactly the kind of quality that I'm looking for here. In the interest of time, I'm going to hop over the functional safety. I will show a few parts, but I don't think I will go into this in detail. But I think that as functional safety is concerned with basically certifying that a system is safe to use and will not cause either loss of life or economic loss or damage to people or the environment. There are 3 types of regulated industries. For instance, in the financial industry, but there are some others as well. You can basically operate freely, but you at any point in time can be requested to provide the evidence that you are following regulation. And then you have industries that are allowed to self-certify. So automotive has worked very hard on, for instance, ISO 26262, which is a standard in automotive to prove that cars and the functionality in those cars is safe. And then there are industries that are required to use external certification bodies. And this is what you, for instance, see in healthcare. And what we see is that the ops part or the DevOps part is in different stages of maturity in these industries. But there are several approaches that are trying to combine agile practices and preparing for DevOps together with safety critical software. And again, I will not go into details, but what is important to remember is there are 5 common characteristics. There is continuous maintenance of the safety case for those of you that are working on functional safety. You use extensive automation to collect evidence. You focus on taking thin slices of functionality throughout the process and get them out as fast as possible. That's why you do DevOps in the first place. You use not only the pre-deployment testing and data collection and automation, but you also use post-deployment. So once you start to deploy products in the field, you collect data to figure out if there's any reason to assume that the system would not be operating according to its specification. And this then is combined with a gradual rollout of functionality. And there's Safe Scrum for those of you that are interested in this, which is now actually accepted by a number of the certification bodies. Safe Scrum is very clear about the continuous safety case maintenance. A company from Norway run by a few people from Great Britain focuses on automated evidence collection. So you actually have a continuous and immutable record of everything that has happened. So you can show very easily that you're compliant. The thin slices is very much concerned with the whole notion of what we call a continuous compliance. And then post-deployment monitoring is part of SafeOps as well as a few other standards. And then gradual rollout is something that some companies do where they first deploy to a few products and then over time they deploy to more products. So in the interest of time, I will not spend more time on this because I'm out of time. Conclusion. Everyone looks really relieved to see a slide that says conclusion, but I hope that this was at least somewhat enlightening and providing a bit of a different view on what we call quality, which I think is a bit of a difficult term. Due to digitalization, we are entering the age of ops. We have DevOps, getting software out on a rapid basis. We have DataOps, where we continuously update and improve the way that we collect data. And then we have MLOps, which is basically concerned with getting updated machine learning and deep learning models out into the field. This requires us to broaden, I believe, this notion of quality in software engineering, because I don't think that quality is just concerned with satisfying whatever is in the specification or requirements. No, it's actually delivering on the value that the customer really wants to accomplish. And whatever that translation is between the outcome that I'm looking to accomplish and the requirements or the functionality that gets built either through a spec or through as a hypothesis to deliver that value, that's a different thing. But the customer doesn't care about the requirement. The customer cares about achieving the outcome that we care about. And here we have software, data, and AI, which I think are the 3 topics that are the key ones here. And I believe that as a community, and I view, of course, your conference also as part of that community, I think we need to broaden our view of quality, and we need to start to develop tools to more effectively address this broader notion of quality. What does this actually mean in practice? I have a bad habit that I'm trying to kick, and I'm almost successful of writing shorter and longer books. The book that you see most on the left is, I signed the copyright to CRC Press, so you will have to buy that book if you're interested in it. But the 3 books on the right of your slide, Using Data to Build Better Products, Impactful Software and Digital Transformation, I give away for free in PDF form. So if you drop me an email on jan@janbosch.com, I can send you a copy of those PDFs quite handily, either somewhere during this week. And with that, 1 minute over the 70 minutes that I was given as a max limit, for which I apologize, I would like to thank you for your attention and would like to open the floor for questions. And once again, I want to thank the organizers and you as an audience for inviting me and giving me the opportunity to share my view with you. Thank you very much.
Thank you, Professor Jan Bosch, for your exciting, insightful presentation. We had almost 8 people in both YouTube and Zoom. It's a great audience. And now we have some time for questions and discussions. We have almost 5 questions, I guess. Let me check the questions from YouTube, Zoom, and Discord. At first, we have Francisco Erivaldo Fernandes Jr. Dear Professor Jan, recently, the public opinion about indiscriminate collection of data has been challenging. The recent case of the Facebook papers showed that the companies need a new direction regarding the data collection. How can we still collect data and perform machine learning without exploiting the privacy of our users in the future? Is there any new studies or paradigms regarding this problem? Thank you very much.
Yeah, no, and I think this is a really good question, and I really want to thank the individual asking it. We have to distinguish between different types of data collection. If we look at the Facebooks and the Googles and the Amazons of this world, they are collecting data with the intent of creating profiles associated with individual users in order to use that profile to more effectively match ads with your data. That is one use of data that has become highly questionable in the industry, and rightfully so, because I believe that that causes a breach of privacy that I think is not acceptable in a Western or modern society. Having said that, I do want to stress that most people, when they have to choose between paying with their money or paying with their data, are still perfectly fine with paying with their data. So I also think that we see an interesting situation where people are very worried about sharing data in general, but when given the choice between paying for functionality or paying with their data, paying with money or paying with data, they still are okay with the data being used. But I'm not going to go into that one. The type of data that I'm talking about here is typically anonymized and aggregated. I don't care who used version A and how they used it of a feature, or who used version B and how they used it. What I care about is, on average, for my entire product population, completely anonymized, completely aggregated, is version A performing better, or is version B performing better? And I believe that that's a different type of data usage, which, to be honest, is perfectly legal in Europe as well as in other parts of the world. And I see much fewer, actually, I don't see any ethical concerns with that. I think there we basically have a situation where data is used to build a product that is superior to what I want to use, rather than a product that is actually worse. And one of my sons was a great really focused on privacy and not sharing too much data with companies on the internet. And he used DuckDuckGo as a search engine. I'm sure all of you or many of you know DuckDuckGo. But he switched about a month ago back to Google, with the reason being that the quality of the search results on DuckDuckGo is much less than the quality of the search results on Google, because Google knows more about what he's interested in, and because of that, Google can give him the answer that he's actually looking for. So he just views this as an efficiency. So it's a bit of a long-winded answer to the question, but I just wanted to provide a little bit of a color commentary on the topic.
Perfect. We have another question from Edson Oliveira. The product process project, big data availability and processing are strongly required these days. So do you understand that actual development and quality team have to concentrate their efforts first in the data quality, then to the normal software quality?
So, yeah, you know, I am always very skeptical on, should I do this or should I do that? Whenever I get into such a dichotomy, the answer that I typically give is I want both. Customers do not accept low quality products. So we cannot sacrifice the normal software quality. What I'm trying to do in my talk is state that focusing on normal software quality is no longer sufficient. We have to also focus on ensuring that the quality of the data is sufficient and good enough, because more and more products are using data in as an integral part of the system functionality, and the system will start to behave really poorly if it gets poor data. And I think that that's an important thing to remember. So it isn't that normal software quality is no longer important, but there are two things. One, just running tests to prove that you're implementing the requirement specification is not enough anymore. Yeah, because it's not about the requirements. It is about the outcome that the customer is looking to accomplish by specifying those requirements. And if you don't spend time thinking about that translation, I think that you're basically shooting yourself in the foot and you're not acting in the best interest of the customer and yourself.
And another question from him, data must be in a proper way to be at least used, reused, and created for prospective use. Do you think open science practices such as open, fair data procedures might inspire a common ground modern quality conceptualization fed by AI-based decision-making processes and continuous experimentation?
Yeah, I really appreciate the question. Yeah, so let me tell you a little story. When I worked for Intuit, I was responsible for the MIT Media Lab relationship. And are we still live streaming? By the way, okay, then will not mention too much, but let's put it like this. Some researchers went out to some shopping mall in the US and basically with a big box of chocolate and said, give me your password in return for a free piece of chocolate. Yeah, they had to get new chocolate 3 times because everyone and their brother was willing to throw their passwords at them in return for a free piece of chocolate. Yeah, that gives me the feel what we're talking about here. Now, in general, companies and their customers have to be open and explicit about how do we work with data. And what we see is that in many end user license agreements, there's quite a clear description of how the data will be used. Do I think that open and fair data procedures are a good thing? Of course, I think that that's a good thing, but it may not be applicable to all companies and to all contexts. One of the topics that we do in our research is in places where the data sharing and centralizing all the data in one location is really a problem. That's when we move towards what we call federated learning. Yeah, so we have a few cases where rather than bringing all the data to a central location, what we do instead is we have federated learning algorithms on each individual device that use the data locally without sharing it and distributing it to train locally on a car, a telecom system, a radar system, a truck, whatever. And then they share model updates with each other rather than sharing data with each other. And if you do that, you don't have to worry about data and privacy and all these other good things because the data is never shared. Yeah, the data is only existing on the system itself. So if these, and this is a little bit case specific. Yeah, I mean, you can say, you know, I want it to be a secret how much money I make, but if I in Sweden send an SMS to the Swedish tax authorities, they are by law obliged, and I send an SMS with the identity number of the individual, they are by law obliged to send me back what that person filed in taxes last year. So that is considered to be public information in this country. And so I think that it's really case specific how to think about data. And I appreciate the questions, but I think it's a bit, you cannot generalize this too much because then you basically create so many exceptions that make no sense anymore, that I think it's important to understand what are we talking about here. Rodrigo, you look extremely unhappy. Did I hurt your feelings?
No, it's okay. Let's move to the next question, Jan. Several questions here. Time for the interview. Elvio Jerônimo Jr. From YouTube. Professor Jan, thanks for the excellent talk. These are interesting topics for me. I have some questions. The first one, what are still the main challenges for software organizations to adopt the Devops and continuous improvement practices in their projects?
Yeah, so the main challenge is twofold. One, the rest of the company is not ready to adopt DevOps. Yeah, so I am a car company. It's not just about the software in the car. It is also about the R&D, the mechanical parts, the electronics parts, etc. So, for instance, in one of the companies that I work with, that shall remain unnamed, the data bus was sized to such a limited bandwidth that updating the software in this particular product on average takes 3 days, because it takes so much time to push all the code, all the software into the product, that it just takes forever because the bandwidth is so narrow, because someone in the hardware R&D department decided to go through a cost-cutting exercise by taking the smallest bandwidth bus that this individual could put in the product. So that's one of the things. So that's within the company. And then the second part is not all customers are equally interested in moving towards a DevOps approach, because it may bring cost on their behalf. For instance, in the airline industry, whenever you update software that is exposed to pilots, for instance, this software needs to be certified to some extent, and the staff needs to be trained, because they want to avoid the creation of safety critical situations. And then the cost of every software release becomes much higher. It's not just getting the software out there, it's also getting the training and the certification, everything else done. So those are some of the challenges that I see companies run into.
Perfect. Again, another question from Elvio is, could technical debt, internal quality issues, for example, be observed or managed in a scenario of digital companies by using continuous improvement and DevOps practices?
Oh, this is a great question. Oh, Rodrigo, you muted before you stopped talking, I think, but I'm not sure. I got
no,
the
it's okay. No, it's okay.
There, for the last Tech Debt conference of this year, I actually do a talk about technical debt in the age of ops. So if people are interested, I recommend that they go there. But the idea basically is that in this continuous cycle, I add new functionality, I fix defects, And I also fix technical debt issues. So I think that the person asking the question is spot on. So I think that yes, it's actually very suitable to integrate this into a context of continuous improvement.
Great, yeah. Now questions from Guilherme Horta Travasso, Professor Guilherme. Hi, Ian, many thanks. It has been nice to listen to you as usual. It seems that software testing is one of the main quality drivers in this overall model. I wondered how to deal with testing the variation of the context awareness features in this development scenario. Any clue?
Yeah, and sorry, this was about variation, right? So having many variants of a product, basically.
Yeah.
Yes, and there's actually an interesting thing happening. One of the companies that I worked with used to have tens of thousands of variants of their product portfolio. And they have a very active initiative ongoing right now to reduce the number of product variants because of the quality assurance cost in a DevOps context. And actually, in 4 minutes, I have a meeting on exactly that topic with one of the software center companies, which is kind of interesting. Yeah, and so what I see is, on the one hand, I see that companies are actively pushing to reduce the variance space in order to simplify the DevOps problem. So that's the first thing. The second thing is you need extensive automation. For those of us in the product line community, I think many of you know of the company Pure Systems with their product Pure Variants. And what I see is that you can no longer rely on manual processes for deriving all the product variants. You now need automated solutions for product variants to be in place, because it is infeasible to run all the tests every 2 weeks or every 4 weeks for every product variant fully manually. So you need full automation, and that's what I see many companies moving towards.
Ian, Guilherme Travassos text here that IT is not the variance of products, but the variation of the context that influences the behavior of the products.
Ah, right. Okay. So then, yeah, so there we see two approaches. One, if you look at traditional A/B testing, you basically try to create a big enough A pool and B pool to make the variance of contexts no longer relevant. Basically, these average each other out. Now, you can question if that's the right way of doing things or not. That's the one side. The other side is that some of the companies in the software center that I lead are exploring ways of adding reinforcement learning to their systems with the intent of allowing each system to adjust and optimize itself for the context in which it is operating. So if I'm a car and I run in northern Sweden, all I see is trees and reindeers. So then I want to be optimized for trees and reindeers. Whereas if I am the same car operates in Paris, it mostly sees the Eiffel Tower and lots and lots of people in other cars. And then I want to have that car optimize itself for that particular context. So what I see is that on the one hand, I try to abstract away the variance in context, and on the other hand, companies are exploring reinforcement learning as a way to have products adjust themselves to specific contexts. I need to start wrapping up in just a minute, Rodrigo. My apologies.
Okay, no problem. Yeah, we have more questions, but I would like to thank you very much again for being here with us, even virtually. We hope to see you soon in a conference, maybe ICS or in Brazil next year, maybe. I'm sure the participants.
I'm coming over. I'm telling you that. Okay. I tell you that. So.
Great. I'm sure the participants enjoyed your thoughts, experiences, and insights from the quality in the age of ops. My gratitude to you. Now we will stop sharing this session via YouTube. Thank you all for being with us in this special keynote. See you later.
Good.